will be better next time I try. And even if I still can't do it, yeah, you know that I'm gonna stick to it. Yes, it's all about going through it, and I'm gonna tell you why. Whoopsie, whoopsies, I made a mistake and it's okay. It's okay. Whoopsies are what it takes to get better and better every day. Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo! Whoopsies, whoopsie, whoopsie, whoopsies.
I'm a little embarrassed when I look at my drawing compared to this. I'm just not getting anywhere with this. It makes me wanna hide. Aw, don't be embarrassed. Don't hide.
You should have seen mine the first time I tried. It took a lot of whoopsies to look this way.
No one's perfect on their first day. Whoopsie.
Whoopsies, I made a mistake and it's okay.
It's okay. Whoopsies are what it takes to get better and better every day. Whoopsie, 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 whoopsie.
Well, what about this? I want to jump rope, but nope, I just can't do it.
Well, not yet. Come on and practice with me. You'll see there's nothing to it.
Whoa! Whoopsie.
Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo!
It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. I know it's hard, but for long, before it's too dark. Wake up, my love, please don't give up on me. It's hard. Wake up. It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. But I know it's hard, before long, before it's too dark. Wake up, my love, please don't give up on me.
What is up? What is up, you guys? We are back at it again. Another epic day here in 100 Days of Rootkit. I hope y'all are excited for us to continue our epic journey. Today's gonna be a little bit more chill at first, all right? We're going to be just chatting, right? Going over some cool modern technologies, and then we're going to switch gears over to the not brand new, but beautiful world of Python that we all have came here to, love. All right, over time we came to love it. All right, so we also have one special surprise thing to reveal to you guys today as an early sneak peek. All right, so let me go ahead and finish up our intro here. If you don't know, we are Rootkit, a nonprofit organization based here in the US of A. Don't go to college, don't go to any other boot camp. Just simply attend. Wait, you are attending, you're here right now. And watch all 100 days so you can learn everything you need to know to get our comp sci cert. If you get our comp sci cert, then you can get certified, take our certification exam, and then get a job. It's really that easy, all right? There's nothing extra you have to do. On top of that, we give away a bunch of free stuff every single week. If you go over to our blog, there's the week 12 giveaway that's live now. Enter today to win. We're giving away 3 different merch items, so make sure you enter. All you have to do is press the green button here and put in your information. And then to gain more entries, you can prove that you're subscribed to our YouTube channel, following us on Twitch, etc., various other tasks. All right, super easy. Win some free merch. On top of that, there's a link in the description of the video. It's not auto-saved here. Let me pull up the stream. Where's the stream? If you look at the bottom of the stream here in the description, grab that link. There is a link to our charity event. We are a charity, so if you donate today to us, you can avoid your taxes. All right, avoid your taxes, donate today. It's 100% tax deductible. Depending on how much you donate, you can unlock certain rewards like our epic stickers, our collab t-shirt, or epic sweater, which I got on right here. Has the Rootkit logo on the back. Super cool. All donations are matched 1-for-1 for the first 10,000 donations. And then depending on how much you all donate, we can hit certain pillars like streaming for 24 hours straight, shaving my head here live on stream, which, all right, and shaving my beard, which, no, all right, no one wants to see that, so we don't need to get that one, all right? That's just cruel and unusual punishment. Alrighty, that pretty much concludes our intro here. Are there any questions from the previous days that you guys would like to go over and talk about before we move forward here on our journey? Just checking the chats here. Alrighty. I don't see any questions, so as always, drop in a question anytime you guys have a question. Additionally, I am in the events chat, so if you are a Patreon or Discord premium member, hop in there, all right? Hop in there and ask your questions, all right? No reason not to, all right? Feel free to interrupt at any single time. Well, as you can see, I guess we have 2 announcements. Our hackathon is happening next month, so make sure you're paying attention. You turn on alerts from our guide here so you can get notified about it, and don't miss out on the event. All right, there's gonna be cash prizes you can win. It's gonna be super epic, super awesome, and a bunch of other awesome fun stuff. We're going to be doing a bunch of classes following up to it in regards to machine learning, but also exploitation. If you've been watching along, well, you've already been learning about different types of exploits that may or may not be there during the capture the flag, or hack the flag as we call it. Also, we are here to announce a product that we've just launched. All right, we pretty much ported it directly from how we use it currently, so you guys may or may not be aware, all of our shorts right now are completely auto-generated. The scripts and the audio themselves. We've cloned recently my voice and a bunch of other famous people's voices, and we just quickly churn out videos with little effort. We now have made that product openly available to a bunch of people in its beta form. So if you go over to deception.rootkitsgarage.com right now, you can get access to this epic platform. And please load. https:// there we go. You can enter now and ignore the the broken little image there. All right, go ahead and get started on your journey here. It allows you to do auto text generation of scripts or any other things that you want to potentially auto generate. It has pre-made styles for, you know, talking like people that you may want to talk about, like, and there's the highest quality available voice generation system ever on the internet currently right now that you can get access to. We are currently adding more and more voices every single day. If you have any voice recommendations, please put them in the Discord and ask. All right, and we'll add them. All right, we'll add them. We've gotten a couple. If you have any features that you want us to implement, let us know. We've gotten a couple recommendations already, and some people want to, what do you call it? Have it so you can clone your own voice, which we've gotten a couple asks. Maybe if there's some more asks, we'll speed it up on the timeline. But yeah, it's completely free for you guys to use right now. You can just log in and create an account. And bam, you can start using it right off the bat. It's 100% free for a certain amount. All right, there's a free tier. So if you look over the pricings page, it's super cheap pricing for the text generation and the audio generation. We charge per character. For the text generation, it only starts charging at 10K. And if you don't have a card on file, it will hard stop you. So you just can't generate anymore. It's auto reset at the end of every single month. So bam, if you don't want to pay, just wait and then you can generate more. And then it will charge you after that for this much. Same thing with the auto generation. You get 1,000 characters for free for auto generating into whatever voice you want. And after that, it just costs a little bit. So have fun with it. Let us know what you think. And yeah, if any questions on that, let me know and we can chat about it. Let's go ahead and move on here to Bing. And we're going to talk about frameworks, right? We're going to talk about frameworks because vanilla JavaScript is not really used that often anymore. All right, people will usually use some type of framework on top of that. Now, originally JavaScript was built and made for browsers and browsers only. But the community around JavaScript is really hardcore. You will not find, I think, any other community more hardcore than them. Even so, you know, Rust fans and Golang fans have notoriously some pretty hardcore cult-like members. I don't think they even get close to the JavaScript/TypeScript cults, all right? Because they have taken and morphed this language into things that should have never been in the first place, but now it is, all right? So through the use of third-party packages, you can now use JavaScript to run not just your front end, but your back end. So remember how we made the whole API back end in Python? Yeah, you can do that in JavaScript now. Through the use of various different applications. One we talked about was Bun, and another one is going to be Node, just Node.js. So these are going to allow you to utilize JavaScript as a runtime environment. So this effectively means it can run on the command line. And same thing with Bun. Here we go. Bun allows you to do the same thing. There's also another thing called Dino. I haven't really used Dino very often. or not very often. I haven't used it at all. So effectively, to use pretty much, I shouldn't really say that. To get the most power out of these frameworks, you have to download and install Node or Bun. Install Node. Bun isn't officially released yet. It's still being debbed. It's not on a stable 1.0. You can use it if you want. I am a big fan of it. I am very eagerly waiting for it to hit 1.0 so we can start using it internally. Effectively, Bun is like a million times faster than Node.js. They have some graphs here on how much faster it is. To be honest, I think they're being very courteous, because from my personal tests along with Snow, we found that Bun is a lot faster than they're claiming. Right, way faster than it claims. So it's quite impressive. So fast, it's actually faster than Python at a bunch of tasks. So it's pretty mind-boggling, because JavaScript, it generally has been really, really slow, really crappy. Like, if you want to make something, you can make it in JavaScript, but it's not going to be great, because again, it's not meant to do this, but now it can through these runtime engines. Because of the great people at Bun, now it's actually viable. All right, it's faster than Python, so you could potentially even recommend it more than Python, but you have to start with one of these as your base. All right, as your base. Now you can run it as you would run the Python language via terminal and run JavaScript scripts via the terminal. When you can do that, then you can upgrade and see the full power. They have a part of these, specifically Node, a package system similar to pip. All right, similar to pip, and that's going to be npm. So if you go to npm, you can go and view a bunch of epic JavaScript packages here. Now, not all of these require the usage of Node. Some of these packages you can download and just use in your more vanilla application, but this is where you can find a lot of great stuff. Is there a way I can like view the top packages? Maybe not. So anytime you want to install packages, they will be pulling from this npm site. All right. Now, frameworks for web development. There's a lot of frameworks out there. We're going to go over some of the biggest ones. And you guys can go Google, search, and learn about them, and probably find more frameworks. There's so many of them. So the first big one to replace jQuery, well, not really replace jQuery, but it was it was kind of the first really big one when Node.js came out, was one called Express.js. Now, Express.js is, like it says right here, a web application framework. It's effectively the equivalent of Flask, right, for JavaScript. So you can load this up and now have your JavaScript be a backend server, start having hosting APIs and query out to this. You can also use this to serve up web pages and make an entire web server and a backend all in one place with Express. That's the biggest power and why a lot of people like making full stack applications with JavaScript, because it's one language for the whole stack and everything's kind of seamlessly integrated with each other. What do I mean exactly by that? Your front end's written in JavaScript, your back end's written in JavaScript. They're passing variables and information to each other in JavaScript. There's no weird conversions or processes you have to do. It's just all JavaScript at the end of the day, which is very convenient and very nice and can potentially speed up on development time. That's something you as a developer always need to evaluate, more so as you get into more senior positions, is, you know, the cost evaluation. Is developing in this language worth it? Because you have to look at the speed and time it will take to develop with the server costs. All right, developing everything in C would be great. That's extremely slow. Developing everything in assembly would be great. It would be pretty much the fastest you could possibly make something. Except it would be so god awfully slow to just get anywhere. And that makes it expensive because time is money. Your time, every hour that you're alive, is worth some dollar amount. All right. If you are developing, specifically for a company who has hired you, every hour that passes is money they are losing. So as time goes on, they're losing money. So you got to balance the quick turnaround with, potentially a quick turnaround with the costs of the servers and balance that, etc., etc., etc. So all just complicated things. Just keep in mind. Now, Express has been I'm not quite sure how some of these libraries utilize their hosting functionality. I want to say they built it from the ground up, so they don't use Express anymore. But no one that I know of strictly, again, you should ask Snow about this or follow some front-end JavaScript dev people, really uses Express as their main backend anymore. At least for most of their just straight up web applications. They'll use some type of full stack capable framework like React, which is one of the most popular ones in the world. React is a framework that allows you to, originally it was meant for building your interfaces. Well, not originally, it's pretty much just meant for that, for generating your interface, your website very, very easily. All right, and painlessly. I really like React. I use it all the time for a lot of Rootkit's personal projects, so I'm a big fan of it. There are some competitors to it, which I'm eagerly watching, but React is the biggest. Now, the biggest doesn't mean it's the best. A lot of times usually means it's not the best option, but it's the biggest one, which means it has the biggest community, the most help, the most support, and the most add-ons specifically for this framework. So that's all a lot of stuff to incorporate in your thinking process. If you're building a big project at your job, you may want to go with React, not because you may personally like it, but because there's just so much support and things built and ready to go in this language that you don't need to potentially waste a bunch of extra time rebuilding things from scratch. So pros and cons. React allows you to use it in a bunch of different ways. One way is to simply copy and paste the script link right into your code, kind of like how we did Bootstrap. Remember Bootstrap? We just copied that script link, pasted it right in our code, and bam, we had it running. All right, we had Bootstrap live in our code. You can effectively do the same thing with React. That is one way to run it, and then there's more in-depth ways to run it where it's more of your application instead of just JavaScript on top of your application. I've used it maybe once or twice a long time ago as just the script version where you just drop it in and use it as a LinkedIn script. So I can't talk too much to it. I usually use it in its most integrated form. I don't even remember the exact verbiage between them. Here we go. One's a React app and the other one's just adding it to your site. So some of the competitors to React would be Vue.js. I guess I should also mention React is made and managed by Meta, aka Facebook. All right. So they're really contributing a lot to the world. They kind of own a lot of the dev worlds in regards to React and PyTorch. PyTorch machine learning library in Python, they own and maintain. React, one of the most popular front-end libraries, they own and maintain. To show you guys real quick how easy it is to, so I guess these are the script tags you can just add real quick to get it up and running. How easy it is to do something in React compared to something else, or sorry, in vanilla JavaScript is, I guess, these are examples, I guess. I don't know if these are great examples. Can I see let's see. We got a hello world example here. Let's see another example here. Not the like best. I guess this one's a really good example right here. So you can basically take your variables. So here's your HTML that you want to render out to the screen. This might look a little confusing, but this is how you're going to render stuff out to the screen. But instead of us having to search by ID and get the ID and then change the text in there and, you know, do all that large process that we saw, the inner HTML, worry about cross-site scripting to a certain extent, a lot of that's pretty much alleviated and gone out of the box. You can simply embed your variables or usage of functions. As you can see, we're running a function right here, this format name, and putting the user as a parameter inside of it, and we're running it, and it's going to render it out right here in the HTML, just like that. No having to learn this document dot blah 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 blah. It just works really easy. You can embed stuff right away, which is the super awesome power of it. All right, all of the vanilla JavaScript things you know that we went over work here. They're all relevant here. They're the exact same here. This is pretty much a new language per se built on top of a language. That's how a lot of these JavaScript things kind of work, is they're pretty much languages built on top of the language, except they are the same original language but with new language. I don't know, it's a little inception-y. All right, it's a little inception-y, but they're super awesome. Vue.js is I think it was originally made by just one individual dude, and I'm pretty sure he has a whole team now. Evan Yu created it. So he was working at Google, and we'll talk about AngularJS just in a second. But as you can see here, it's a lightweight version of Angular, I guess. I've only used Vue a couple of times. So let's go ahead and go to the Vue.js site here. So Vue is a big alternative that's really catching on and people are really enjoying. I haven't dived into it too much because when we here at Rootkit were recently evaluating which framework to go with, we did like Vue, but we didn't go with it only because of the developer and mod support. Like I said, just because React's the biggest doesn't necessarily make it the best one to go with, but all of the support and extra things you get with React just made a no-brainer for us, specifically with one thing in particular, which I'll talk about in just a second. So I am very happy to see Vue continue growing, and I hope they become super big and a good alternative. You can see a lot of people use them. They are very popular. They're just smaller, not like a lot smaller. They're actually pretty large right now, but they are smaller than the React community. And it's pretty much just as easy to use Vue as it is to use React. All right, for the complexity wise, it's not like it's more complex or anything like that. They're both pretty darn easy. So you can see here, here's your JavaScript right here. You have a variable that's called message. All right, the formatting might be a little confusing at first, but effectively you have a variable that's called message, and you can embed your message directly into your HTML. So that's pretty neat. Also, just a little tidbit for you guys, if you're ever messing with any sites or email editors or other various things, if you ever see anything with double brackets or singular brackets, like you see right here, that might be an indicator to tell you what type of JavaScript or library they're using. There's a bunch of ways to figure out what type of JavaScript library someone's using, but that is a potential indicator. But let us continue on to the last super mega popular one. Angular Can I just do AngularJS or no? That's IO. So Meta has React. Google has Angular. Angular's been around for a very, very long time. I'm pretty sure it's been around way before React. Was it like, did it come out exactly? 2016? When did React come? That's actually a little later than I thought. Hold on, I need to know real quick. When did React come out? No, React came out in 2013. Never mind. I'm losing my mind. All right, I swear Angular was older than that. Google said, guess what? We do it better. And they made Angular. Angular is pretty popular. It's used by a lot of large corporations. It's not the most beginner friendly, but it is one of the most robust ones out there. A lot of people will even argue this is the quote unquote best framework to use because it has a lot of in-depth and powerful features about it. But with great power comes great responsibility, and also with great power, it's usually not as easy at first to learn it. Again, without a large community, when you try to get help, it could be a lot harder to find things, especially if you're Googling things. So a large community is really, really helpful for that. But Google uses this, so if you're using any of Google's products, most likely you're going to be using Angular. So you can see here the double curly brackets also. So that could be an indicator you're also they made their platform with Angular. All right. Yeah, I think that a lot of the attribute terminology is kind of hard for people to first learn. As you can see, this syntax looks a lot different compared to the other ones. I mean, they all look a lot weirder and confusinger than normal, but this one particularly has some interesting things going on. But those are the three biggest, most popular frameworks out there. If you want to go down the front end path, you should definitely look at and evaluate all of these and see which one you want to utilize. Again, React, biggest, most popular one, has the most libraries and support. Vue.js, very closely behind, very popular, growing in popularity all of the time. Really good framework. And then Angular, it's enterprise grade. That's all I gotta say. I don't know. I'm not a particularly like huge fan of Angular, but I'm not really against it. There are frameworks that are built on top of frameworks that you can also get in this JavaScript world. It never ends. That's all I gotta say, is it never ends. Yeah, things are built on top of things, on top of things, on top of things. The biggest reason why we went with React internally is this thing called Next.js, which is super epic. It's a framework utilizing React, built on top of React to allow you to build full stack applications. All right. It is super epic, super powerful. I highly recommend it. If Vue had something even comparable to this, maybe we would have gone with Vue. I'm not really that up to date on the Vue community, so you're gonna have to look at other YouTubers to see what alternatives Vue has. Next.js is one of the biggest ones in the game. They are absolutely amazing. So to use Next.js, you don't just need to learn JavaScript, but then you need to learn how to use Node, and then you have to learn how to use React, and then you have to learn how to use Next.js. That's what I mean about JavaScript has morphed into an ugly, disgusting beast, all right? It's absolutely insane and gone wildfire and crazy. It is. And then there's TypeScript. You can't forget about TypeScript. So we keep talking about TypeScript, but we haven't really gone over what it is. Effectively, this is made by and maintained by Microsoft, all right? So they're trying to get their hand back in the game because they originally had a competitor way back in the day for JavaScript. This is their entry back into the JavaScript game. They have TypeScript. Effectively, TypeScript is a way to make your JavaScript even more annoying. All right, it's not actually annoying. It's actually really, really great and really, really powerful. But for new people, it's super, super annoying. So if this is normal default JavaScript where you have a variable that you're making, and in this variable you have, first name, last name, and role, and then you're going to print it out onto the screen. This is cool and all, except TypeScript allows you to add typing to everything. This is something that was added to Python, and we've seen it a little bit before. So typing in Python would be when you say, oh, this is going to return an integer, or this is going to return, this class, or it's expecting, a variable of this type, like the float type. That's basically what TypeScript is, but it enforces you to adhere to its will. So here's an example of what TypeScript would kind of look like. Is this, if I hover over, no, okay. So this is what it basically looks like. So you would say that you want to make an object called user, and you're going to have an ID variable, and that ID variable is going to be a number. And then first name, that's going to be a string. Last name, that's going to be a string. Role, that's going to be a string. You're going to take some variables in. The variable number 1, this ID variable, is going to be a number type. Update is going to be this partial user type. All right. This syntax may look weird to you. Don't worry about it too much right now. It's effectively a way for you to type everything, but not just for you to type everything. It forces you to do it. All right. So that's a whole new other fun thing that you can learn on your JavaScript rabbit hole. Any questions so far? Any questions so far? Again, there are a lot of videos on YouTube for front-end development and full stack using these frameworks I've talked about. Watch those people. They're going to teach you way better than I can on any of these. All right. They know way more about all of them than I do. So watch them instead to learn and get better insights. If you have any questions, Snow can answer most of them. I can answer anything in regards to Next.js and React for the most part. All right, because I'm very familiar with both of these. Let us continue on, shall we? If there's no other questions. No other questions? Man, it would be like the equivalent of us, we've learned Python, and then me saying you need to now learn this new thing on Python, but after that we need to learn this new thing after that that builds upon all of them, and that's actually the new modified version of Python you need to know. I don't know, it seems absolutely insane to me. Absolutely crazy. And then it's very confusing to figure out at first when you get errors, what threw the error? Was it a Node error? Was it a React error? Was it a Next.js error? Was it a TypeScript error? Oh my God. We don't need to go down that rabbit hole. Let's close these before I get some cancer. Oh man. I love this lemonade so much. It's so good, but it's so sour. Is there anything else for JavaScript we needed to cover or talk about before we move back to Python? I don't remember. So we're going to go back to Python. Congratulations, we're back to Python. We're done with HTML, CSS, and JavaScript world. We're back to the safety of everything. So before we get into the Python code, we're going to get into multi-threading and multi-processing. All right. If you don't remember what those are and how they work, go back and watch because it's important for you for passing the exam in the first place. Additionally, you can use your AI assistant to help you refresh on what they are. So let's go over to Bing and let's say multi-processing versus multi-threading. That's an example. Maybe I shouldn't have specified Python. There we go. So again, multi-processing is going to be when you spin up more than one process. And multi-thread, maybe we need to click on this example. This is not going to work. Holy crap. Oh, these are some beautiful pictures here. Continue without supporting. All right. So multi-processing is going to be when you spin up brand new independent processes on your computer. All right. What does it say here? Multi-process CPUs are added for increased compute power. Multiprocessing, many processes can be seamlessly. There's symmetric and asymmetric multiprocessing, processing time consumed processes, multiprocessing every process separate address space. So some of these I like, some of these I don't really care for. Multiprocessing means that you're launching brand new independent processes. So if we're on Windows, if we pull up Task Manager and we look here, you're going to see new entire processes show up here. So if I open up Spotify here, for example, you can see there are 3 independent processes running in the, or I guess 4, because I think the parent one counts as one also in the GUI here. There's going to be 4 processes here that are running for Spotify, not threads, but processes. Those are pretty much almost identical clone applications. They might not be identical cloned because one process could kick off more processes that are separate applications, but they're all going to be attached to the main parent. All right. The big thing is there's going to usually be a main parent, right? A main parent. And you can also view this over in using I'm blanking on the command right. PS tac elf. When you're over on Linux land, you can view all the processes there. Threads, though, you can have multiple threads per individual process. Processes are independent things. They are 100%, their own thing. They run by themselves. They have their own memory address. Each process cannot share what's going on inside of its memory with each other by just sending the address, all right? Just sending the memory address. They have to go through a more formal process to transfer data. When you're using multi-threading, these are linked to your process. They are in the same memory address location as your process. So things that happen on threads, you can share immediately with other threads or the main process if you want. Pretty much immediately because you can just share memory addresses. Also, you can run into issues because with multi-threaded processes, if multiple of them are trying to do something with the same chunk of memory at the same time, that's where you can get your blocking processes. What is the actual term for it? I'm forgetting it right now. Locking, deadlock, right? You can get a deadlock, not exception, whatever it is a deadlock exception, right? You can get a deadlock exception that occurs. And then the other exception that we went over, which is the race condition, can also happen, all right? So you have to be careful when you use multi-threading and multi-processing. Multi-processing can be a little bit more lenient than multi-threading because you have to go through more of a formal process to transfer data from one to another. So it's not as potentially game breaking as threads. But again, threads are way better, way faster. Let's see what they say here for threads. All shared memory space. Creation is according to economical. It's not classified in any categories. Many threads of a process are executed simultaneously. Many threads are created of a single process for increasing compute power. All right. Python is a weird language. All right. Python is a weird language, and by default, you can't really do true multiprocessing. Some of the pip installed libraries that you do that have underlying C code that they're accessing, there are options built into the library to allow for true multi-threading. But by default, when you try to spin up threads, which you can, right, and we're going to go over that here in a second, it doesn't actually do it, right? It's kind of lying to you. Why is it doing this? Because there's this thing called the GIL in Python. There's this thing called the GIL, which is the Global Interpreter Lock. So it's effectively a lock that makes it so Python can only run by default in the interpreter one thread at a time, right? Even though you may spin up multiple threads, it won't work. And this can be potentially a massive performance bottleneck for you, especially if you have a multi-threaded application that you think is working, but you don't really see that performance benefit that you thought you would see. Because the whole point of multi-threading and multi-processing applications is if you have a CPU with more than one core, which you do, all right, your process by default will only really run on one core or take full advantage of one core on your CPU. What if you could run your process across all of the cores on your CPU? What if you're building a server grade application? Servers can have, hundreds of CPUs. Or hundreds of cores on the CPU. So if you could spread the load all over those and run them at the exact same time, that would be amazing. That would be so fast. Think about it. If you were trying to crunch all these numbers, you could do it all at the same time. GPUs have thousands of cores, right? To tens of thousands of cores, right? They're all about parallel compute, which is different than CPUs because they do serial compute. So again, the GIL only affects your main Python. Some libraries that you implement or utilize, like NumPy or PyTorch or etc., are actually multi-threaded, and they aren't locked down to the GIL because there are options to turn it off. What do they have here for their example? I didn't see it real quick, so we're not going to look into it too much. But there are ways to turn off the GIL or to allow exceptions to the GIL. So just know, if you want to do more of a true multi-threaded process, you're going to need to go through the steps to turn off the GIL. All right, so be aware of that. If anything, just remember GIL is a thing that may or may not affect you, that you may need to look into, re-look up, research. All right, any questions on that before we chug along here? I don't see any questions. So let us chug along, shall we? Let's do a multi-threaded example first. Yeah, sure, it's not doing full or true multi-threading. That's not the point. The point is to show it off. The process of using multi-threading in Python is quite similar to how you would do it in C. Again, because a lot of the hardcore low-end Python functionalities are pretty much one-to-one ports of their underlying C equivalent. So if we look up Python multi-threading, we should, why doesn't it, wait, Python multi-threading should bring up the docs here, right? So when we look at the docs here, we can learn about multi-threading, all about them, how to go about them, how to do things like count the threads that are available, figure out what our current thread is, because remember, you're effectively making a bunch of threads that are running all at the same time that have their own logic, and maybe they're all working on the same problem. They need to have a way to identify themselves. So they're usually given things like the ID, type, value. Is these the right? No, these aren't the right ones. We went over it when we talked about multi-threading and processing a couple days ago. I'm forgetting them all off the top of my head right now, so please go back and refer to that day. But they will have things like their current status, an ID that's unique to them, and a couple other items that I'm forgetting right now. So you can check in and see, who is who. So when you have your custom logic, they can all stay in order on however they're supposed to execute or how you want them to operate. Because you're effectively making like drones, little drones that go out and do their own things, or bees or ants essentially. Bees and ants, I mean, like you have a bunch of them and they're doing just little things. They're kind of dumb potentially by themselves, but together they can do something powerful. So when you make threads, and this goes for processes too for the most part, you get options to start them, to run them, to have them join back in. So basically you can recall your threads so that they can go out and do their thing, and then you can be like, hey, come back here, come back, and then they'll come back to you. When they do come back to you, that's when you can extract potentially useful information out of them, because they'll also report back potentially information, and you can check if they're alive or not, and you can set it as a daemon, which is going to be as a background process. And I was looking for another one, maybe it's not a part of the threads. There's also a close, maybe that's for processes. All right, I digress. So there are a couple things we need to be aware of and potential issues that we can run into with our threads, because again, we can share memory with threads. We're all basically a big hive mind where we all share one mind, and we're doing different things at the same time, but we have one singular mind. That can be potentially troublesome when we try to access the same resources at the same time, or someone's trying to change it while someone's trying to access it, or two people are trying to change the resource at the same time. So to avoid those issues, you're going to apply something called a lock on those resources, effectively playing not tag. I thought I had a good example, but I can't remember it right now. It's effectively the same as if you go to the library system, or a library in the system there, where you want a book, you go, you grab a book, you fill out your information, you check that book out, and only you have that book now. Even though other people may want that book and want to read that book and use that book, they cannot until you return it. The lock system is very similar to that. To ensure that people aren't messing up a variable, and you get into a deadlock position, or technically this causes a deadlock position potentially, is you lock everyone else out of that variable until you're done with it, and then you give it back, you release it. So this is what this locked section is about. I don't know if this lock section is specifically for your variables or not, because the docs aren't really, they're kind of all over the place. But you can go about asking for a lock. So this is going to be a blocking true by default. What does that mean? Well, you're going to let me read this before I say anything. When invoked, the blocking argument true by default block until the lock is unlocked. Yes. All right. So when you try to acquire something, if I have a book and you want to read the book, if you're trying to acquire it, your thread will effectively freeze and stop running and wait. It will sit there and wait and wait and wait until I am done and I release that resource that I was using. Once I release it, then your other thread will continue forward until it is done. All right? Until it is done. So these are super, super useful. And a way you can go about doing locking of items. There's a bunch of different ways you can lock stuff. Another way is using a semaphore. So you can use a semaphore, which is effectively kind of like a pipe. Is it a pipe or was pipe? There's also another thing called a pipe. But effectively, it's the same way. You can lock up resources until you're done, and then you can release them. All right, this is a low-level call. This is for straight up the underlying C that you're calling, and you're utilizing here with your semaphore. And we talked about Dijkstra's earlier. Very busy man. Did a lot of great things for for the computer science space, right? So these may or may not make sense to you right now. That's fine. The big thing you need to know and take away from this, because we're going to show examples here in a second that you can then now utilize and see the actual power of, is that threads, we're going to do threads. Threads like a hive mind, sharing the same memory space, but like a hive mind, things could potentially go wrong because we have one big brain. If we want to do stuff with the same resource at the same time, that's usually when you're trying to change that resource, you're going to want to lock it up so you have access to it only and only you. So, and by you, I mean that thread, because if you have 100 threads, you only want that one thread to have access to it when changing, and then when it's done changing, you want to release it. All right? Any questions on that before we go on break? And when we come back from break, we're going to get into some coding examples here. Again, this process, very similar to if you were going to do it in C. It's very similar if you're going to do it in C#, C++, not JavaScript, Rust, Golang. A lot of languages are pretty much very similar when you do multi-threading and how you'd go about executing it and also locking your resources. All right, because again, the underlying operating system only allows for a handful of ways of locking up items, one being semaphore, another using pipes, and then another way is also using the Unix networking calls. But I digress. I don't see any questions, so we're going to go ahead and go on break. When we come back from break, we're going to complete a example of making a thread, executing that thread, executing 2 threads, 100 threads at the exact same time, and then showing how issues can potentially arise and how we can solve them by using locking mechanisms. All right, so I'll see you guys in 3 to 5 minutes. Alrighty. Let us get back into it, shall we? And continue our journey here through the multi-threading world. But before that, let's go ahead and redo our intro just for everyone new that is joining us. If you don't know, we are Rootkit nonprofit organization here in the US of A. Don't go to college, don't go to any other boot camp. Instead, you're already here. Continue watching and then you can get certified. If you learn everything you need to know to get our CompSci cert, take the exam, bam, it's just that easy, you get a job. All right. On top of that, giving away all this free education. If you go over to the blog section of our site, you're going to see the week 12 giveaway is live. Go and enter today to win. We're giving away 3 different merch items, 2 t-shirts and 1 mystery item due to things that happened on week 11 and deals we had in place. It's simple. Click the green button, put in your information, and then show that you're subscribed to our YouTube channel, following us on Twitch, other things, you get more entries to win. Also, there's a link in the description of this video, and if you're on Twitch, somewhere down below, if you click on that, you can go to our charity event. We are a charity, so if you donate to us, it's 100% tax deductible if you're here in the US of A. Depending on how much you donate, you can unlock certain rewards, like our epic tax deductible if you're here in the US of A. Depending on how much you donate, you can unlock certain rewards. That was weird. Let us continue. You can certain rewards, depending on how much you donate, you can unlock certain rewards like our epic stickers, our collab t-shirt, and our epic sweater, which I got on right here. Look at that. So cool. Rootkit logo on the back. Additionally, all donations are matched 1-for-1 for the first 10,000 donations. And we have pillars along the way, like streaming for 24 hours straight, shaving my head here live on stream, and the one that no one wants to see, shaving my beard, so we don't need to get to that one, right? Let us continue, shall we? Let us continue. Now, I'm curious. Will the chat here generate us some multi-threading example. Wait, I want to stop. Python multi-threading example. There we go. Let's see if it can generate us some good old example code we can copy and paste right into our Python code, so we don't have to go searching around on the internet thinking or wondering if it will work or not. We can simply just see right here live. Oh, actually though, I'm very happy with this one, because it didn't just make one function for us to use, it made two different functions for us to use in this threading example. So let's go ahead and copy this code. Why is my scrolling so slow? Only when I highlight. All right, let's go and copy this code. And I'm gonna put this off to the side. I don't want that here. Let's go over to our code here. Whoops, make this bigger. Shrink this. Let's make a new folder here for multi everything. All right, we're just gonna call it multi everything. And in here, we're gonna make a new file. We're gonna call this multi-threading.py, and we'll go and paste that example code. All right, you don't have to go through this setup. This is how I'm doing it, so everything's kind of organized. So multi-everything folder, this is where we're gonna do multi-processing in and multi-threading in. And inside here, we're going to just make a script called multi-threading. You could call it main.py or something else if you want, and we're gonna throw that in here. Now, before we run this, I want to take a second to read what it has here as an explainer. This code creates two threads that run concurrently at the same time. The first thread prints even numbers from 0 to 20, while the second thread prints odd numbers from 1 to 19. The start method starts the thread, and the join method waits for them to finish. I like that. That is a really good answer, right? That is a really good answer, and I think just about anyone that asks this will understand what is going on here. So we got two functions here. Now, without running them as threads, let's first run them normally, right? Let's first run them normally. So if we say even, and if we say odd, all right, we're going to run the even function first and the odd function second, all right? Even function first and the odd second. Even should print even numbers from 0 to 20. Odd will print odd numbers from 1 to 20, which 20 is not an odd number, so it will stop at 19. So if we cd into our multi-everything folder, and then we do our Python multi-threading and press enter, you're going to see that it prints out, all right? And it's exactly what we would expect. The even function runs first from 0 all the way to 18. I guess it doesn't print or include 20. And then the next one goes from 1 to 19 because it's printing all the odd numbers. Nothing crazy here. Nothing that's trickery. This should be very expected from everyone here. It's just printing out numbers. The big thing, the important thing here is it's printing out all the numbers here first for even, and then printing out all the numbers here second after even is completely done for odd. All right. That is what happens when we're on a singly threaded process. So by default, when you run your Python script, you're getting a process, and inside that process, it has one thread. That's the main thread that everything is running on. So when we talk about how it reads from top to bottom, it's reading top to bottom because it's on one thread inside of a process that is going to execute every line one at a time going downwards. We can change this by using multi-threading. So what's going to happen here is we're creating two new threads, right? They don't get fully created here. This is like the template for them. So the template of them has effectively been created. We've made these thread objects here. When we're making a thread, we have to use the pre-built threading library that's built in. Inside of the threading library, there's a bunch of functionality that you can access. If we do the dot here, you can see a bunch of it here. We're specifically going to be accessing this thread object, which it's a constructor this is the constructor for creating a brand new thread. All right. We can give it a optional argument called target. Target is going to be the function we want our thread to run. Now remember, threads, shared memory, so you must define the function within, all right, within itself, within the main process, and it's going to be referring to that, all right? It's going to be referring to that one. Every thread can only run one main function. So our function here is the main function. It runs the main function. All right. We don't have a main function right now, but it runs the main function. These are going to be running the even and the odd. To start them, like it said here, we need to do .start on each one, and that will actually spin it up and have it start running. This happens one after the other. So T1 will start, and then T2 will start. These will run and stay alive. They usually won't auto die unless you do .join. .join will absorb them back in and they will be gone. Join is a blocking process. What do I mean by that? Your main thread here will not die or close or end until all threads are reabsorbed. If they can't be reabsorbed, then your process won't die and you're going to be just hanging there, which we'll go through an example of that here in a second. So let's bring up our terminal here again and let's run this example, but with our threads. So if we press enter, you're going to notice you may at first not, be like, well, did it actually work? I don't know if it worked. Well, you can notice here that it did work. And how do we know it worked? Our output doesn't look very organized anymore, because before we had it so all of our evens would output first, and when they were done, and only when they were done, we would move on to odd and start printing out all the odds. Now, if we look here, that's not the case anymore. We print a even number, an even number, an even number, an odd number. How do we print an odd number? Because the second thread we have, the odd thread, is running at the exact same time, theoretically, because of the GIL, at the exact same time as the even thread. All right? Odd is running at the exact same time as the even thread. So their print statements may execute on top of each other, which you can see here, they are executing on top of each other. So you're getting a bunch of odd numbers mixed in with even numbers, right? Odd numbers are getting mixed in with even numbers here. So yeah, congratulations. You have now made a multi-threaded application. You've done more than, oh, thanks for the sub, Ruber Blocks. You've done more multi-threading than a lot of devs have ever done in their entire career, which is sad. This process, which I don't want to say simple, I mean, it is simple here in this example, but it can get really complicated quickly, is the reason why a lot of games built by devs, game engines particularly built by devs themselves from scratch, are hot garbo, all right, are hot garbo, because they don't do proper multi-threading and multi-processing, so their application will be heavily dependent on one single thread, which means that the only way for your program to run faster is purely a higher CPU clock rate, because since you're only in one thread on one core, that core needs to run faster in order for your program to run faster, which is different than if you spread your program out horizontally. Instead of having it as a vertical stack, horizontally spread it out, So if you use multi-threading and multi-processing properly, now your performance won't only just scale on clock rate, but it will scale on how many cores someone has. So the more cores, if you have this on a server, it should run potentially exponentially faster than someone that has a dual core computer, dual core versus 100 cores. It should run exponentially faster, all right? This is also a reason why server CPUs are usually way lower on their clock rate than consumer grade ones, because the clock rate usually isn't as important as the core count, because most server grade applications will be trying to take advantage of as many cores as possible so they can run a bunch of things at the same time. I mean, think about it. A million people are trying to access your web server. You want to handle all those million connections. Each one of those connections you effectively want to have as their own thread, and all the cores should be trying to handle each one of those. If instead you had it so all billion connections were going to a program you built that was singly threaded, that one core is going to be just on overdrive, right? It's going to be just chugging away. And it's going to be looking at all the other cores, the 100 cores that aren't being used, and it's going to be like, wait a second. Any questions on this? Any questions on this? All right, so let us continue. Join is a blocking function by default. So you can set, since it's blocking, when something is blocking, typically you'll get the option to either turn it off so it will no longer be blocking, or you'll get an option here for timeout. By default, it has no timeout, so it will last, at least from my testing, unless they changed it recently, it will sit there forever and wait and wait and wait and wait. It is a good idea in general if you know if things are going to be glitchy, or if you just want, if you know they're never going to take any more than an X amount of seconds, set a timeout here so your program doesn't just hang. So let's say I made a little oopsie here, and in my odd function I said while true and pass. All right, said while true and pass. So this function will run forever and it will never end. So when I try to end my program and pull my threads back in, this will never ever complete. So you're gonna see here, we're just stuck. Our program's just hanging. But even worse than it just hanging, if we pull up Task Manager, you're gonna see it's blowing up my computer right now. All right, we can see this Python process right here is absolutely going insane. It's using 8% of my CPU right now. It's just chugging along, abusing my computer. So it's doubly as bad. We, the consumer, can't close this program, and the CPU is being chugged away. If we try to Control C, you'll notice I'm smashing this right now. Control C doesn't work either. All right, Control C doesn't work either. When things hang like this, it's usually really rough to get rid of them. It's a forceful operation. You've seen this most likely before. For example, you've played games on Steam, right? When you play games on Steam, sometimes those games are a little unstable and they may close or crash, but not fully crash. And when you try to reopen them, it will say the game's already open, or maybe Steam won't even let you reopen it because Steam says that it is already open on your computer. That is because it most likely is stuck in this situation where the main program is trying to close, and it's closed a lot of stuff like maybe the visuals and the audio and pretty much everything you've seen, except there's a couple threads that it's waiting on that just won't close. Now, typically, these devs will build a timeout system in their program, so after maybe 30 seconds, it will auto close. But typically it doesn't mean all the time. So the only way to get rid of this example, when we have a multi-threaded application that's just stuck and hanging, I guess there's 3 ways for us to easily get rid of this. 1, make sure you set a timeout. Or 2, close your terminal here. So if we press the trash can, we can kill the terminal. When the terminal dies, it will kill this also forcibly. Or 3, if for some reason your terminal killing doesn't work, pull up Task Manager, find this pesky process, and forcefully end it. Now you can do it through the GUI here. It looks like it's no longer chugging away. I don't know which one it is here now. Still won't let me end, so I'm just going to kill the terminal. All right, now that I've killed the terminal, if we open up our process list here and view Visual Studio Code, we still see these 2 Python operations. So worst case scenario, we can just kill that Python and kill this Python operation. All right, just to make sure these things are super dead. I think these are from other Visual Studios that we have that I have open. So you could also just kill Visual Studio in general. That should also do it. All right, I guess the alternative is you can go onto the command prompt or PowerShell and kill it via that. If you're on Linux, this happens sometimes. When you try to kill an application that's stuck like this on Linux, you're going to find that kill typically doesn't work. So you're gonna have to kill tac9 it, right? You're gonna have to find the process and then kill tac9 it. That will forcefully remove it. Any questions on that? I don't see any other questions. So let us chug along, shall we? Let's go ahead and remove this while loop so we aren't looping forever and getting this to hang. Well, I guess we could keep it and then do the timeout example. So if we say in here, timeout equals 1 second, and this one, timeout equals 1 second, and rerun this. We got a CD into the correct directory. This is going to call multi-everything and Python multi-threading. There we go. We can see that it should be timing out. Or maybe not. I hate when things don't work like this. Alright, well, I guess it's not going to work for us, so you're out of luck, I guess, for right now. I have no clue why. Unless I just didn't read that correctly. It should be working. Though, like I said, should be timing out. Okay, whatever. We're going to move on. But timeout is there for you to potentially set and mess with. So utilize it when you can. I'm not going to figure out why it's not working right now. Timeout, or maybe I am. When the timeout argument is present and not none, it should be a floating point number that specifies a timeout for operations in seconds. Join all returns none. You must call is alive after join to decide whether a timeout happened. If the thread is alive, okay, it looks like there might be a little bit more setup, whatever. We're going to continue on. We're going to continue on here. So the next thing we can do here is for a thread, you're going to see there's something called args, and name is so we can set a custom name. There's also daemon, but there's a way you can set send arguments to these functions. For example, even here and odd are both functions, and they can potentially have parameters, like let's say my number. How would you pass it my number though? You can do that with the optional arguments here. So let's go ahead and Google, or in this case, we're going to use Bing to get us an example. So Python multi-threading example passing argument. Let's see what we get here. There we go. We got some arguments, and here we go, the arg section. So just like it says here in our args, it takes a tuple, right? Well, not a, it doesn't say tuple. It takes none, or it takes a function that returns an object. I'm kind of confused here. But you can see here in this example, it's going to take a tuple. Oh, we got two examples here. We can give it a tuple of args, and it will fill up arg1 right here and arg2 right here. So if we say my num and go ahead and print my num right here, and we can say on odd that this has args of 10. And we need one more parentheses here. So now we should see 10 get printed out to the terminal. So let's go ahead and cd into the multi-threading and Python multi-threading. And you can see here that we get an error. So you'll also notice that since these are independent threads, if they do error out and print out, they're going to print out really weirdly like this, because again, these threads are independent and happening potentially at the same time. So that's why you're going to see this commingling of error and printouts, because the other thread is running successfully and printing like normally, while the other one is erroring out and then printing out the error. So odd, my number, args 10, print my number. Error says argument after asterisk must be an iterable, not int. So that's maybe why it wanted the parentheses, or the tuple inside of a tuple. No, now it says iterable here. You have failed us. Unless a string counts as iterable. Okay. Fun. You have failed me, and I will not forgive you for this, Bing. So Bing has failed us, right? Takes one positional argument, but 4 were given. Am I just messing up on this? Oh my gosh. Okay, so that's working. So this string works. So why wouldn't something like this work? That does work. Why would the tuple not work? Are you kidding me? Did I not just have a tuple inside of a tuple? Why wouldn't this work? Okay, I guess it wants an array. Whatever. The formatting was slightly wrong for the example that we got here. So we need to effectively put everything into an array inside of the args, and that comma delimited list would be what arg goes where. So we have our cool number here. If we run this, You're going to see everything runs as normal, and somewhere in between this, we're going to see our epic number. Now this is fine and dandy. Reading is an okay, fine operation to do. We can go and set my number here and have it equal to that super long number. This is an okay, fine operation to perform all by itself. When this becomes troublesome is if both of these are intercepting my number, and then both of them are trying to change the number at the same time. So let's say this one's going to make the number 5, and then this one is going to make the number 10. And we're going to just comment out these for loops here for just a second. And let's go ahead and pass the args. Actually, we'll make the args, so my number is going to be plus equal no, that's what my number is going to be. This one, yeah, we want it to be like this. So we want this to be my number. All right, now when we run this, parenthesis right here, probably be handy if we print. We're gonna print right here outside of it, not done. We're gonna print my number. And now you're going to notice that it's not working. These threads have... What is going on here? I think I'm mixing up my thread example here for shared. Oh, I should have prepped these ones beforehand. I'm sorry, you guys. What's supposed to happen is show how inconsistent when you're sharing the memory for this variable to these threaded items, and these threaded items are trying to modify it. You're going to see that if this was working, that it's inconsistent on its output, because sometimes it will output 10, and sometimes it will output 5, which kind of shows the race condition issue, where effectively if you're having something manipulate the same variable at the same time without any locking mechanism, they could not potentially be working with each other, but instead against each other, which you don't want. You want your program to be cohesive and have every part working together, especially if you're reassigning variables. So this is where something like locking comes in handy, and things like semaphore, and this was our segue to semaphores. But this is, I guess, protecting against it, because it looks like it's making a copy of this number. Is it because I'm putting in an array here? What if we, hold on, what if we make this into an array, remove this, and now we want to do my number 0 equals 5. Wait, did we have these names wrong? Why are they going from... Did I just have a syntax error? Okay, you know, I'm not going to question it. All right, let's go ahead and run this and see if this works. Int object does not support item assignment. This will, yes, this will be like this. My bad. I'm in disbelief. Let's see if we can get a bad example auto-generated for us, potentially. So on thread in multiprocessing, we are making a thread directly like this, but this isn't the only way to make a singular thread. There are a bunch of different options in the multi-threading and the multi-processing library to spin up these things called maps. And I forget what the other one is called. So this is a race condition lock, a condition lock, a timer, event object, thread local data, threading.local. Thread local data is data whose values are thread specific. If this is thread specific, then the other one should definitely work, right? I'm confused on one my... Where's the args section? So I'm just irritated now. You know what? I'll figure this out our own time. I think multiprocessing has all the extra items to it. Yeah, right here, thread pool executor. So, okay, they're going to be in the concurrent futures library. So there's a multiprocessing and multi-threading both have their own libraries where you can invoke them directly. There's also extra libraries that build upon it to give you more power. So those are going to be found in the concurrent futures library. And inside there, you can find things like thread pool executor, where effectively this is a wrapper on top of the thread function where you can make it simultaneously spin up a bunch of threads, 1, 2, a million. Because right now, if we want to, where's our code? If we want to spin up a million threads, you know, we would have to put this in a while loop and then keep track of everything, join everything, etc., etc. This pretty much does it automatically for you with some extra functionality potentially. You can give all the names threads, so it supports naming threads, so you can just prefix it with something. You can initialize it, and you can give it its initial args. So this usually, initial args, I believe is, at least for this one, is the way you can dictate how many workers are spun up. So if I give it 10 arguments, it will spin up potentially like 10 workers. I like this example they give here down below. So you can see this multi-threaded application here is effectively going to be going to all of these websites at the exact same time. Because if we wanted to visit each one of these websites and scrape the information off those sites one after each other, it could be potentially very, very slow and take a long time. But instead, if we did them all at the same time using threads, now that's really, really fast. We can potentially speed up our application by 1, 2, 3, 4, 5 links we're visiting by 5 times the speed, right? By 5 times the speed if they're all potentially happening at the same time or at the same time. It's not exactly at the same time, but it's as close as possible. Yeah, there's a bunch more here. I think we're gonna just cut it there for today so I can build out these examples, because these ones I need to build them out before you guys, before the class for you guys, so that way we're gonna have a smoother transition, because I don't want to sit here having to search everything for you guys. So that was our little intro to multi-threading. We also again talked about the JavaScript stuff and the libraries. So if you're interested, now you have a path to go look down stuff for threading. Hopefully this was a slight refresher for you guys. Go back to the other video and watch them if you need to. Play with the multi-threading, right? Maybe try to cause this error that I'm trying to cause right now, but play around with it. See if you can, you know, implement it in fun, cool ways, or if you have any ideas with implementing it, all right? Because threading is important, multiprocessing is important, is important. I'm saying this a lot for a reason, for the exam. It is important for the exam. So make sure you can do it, right? Make sure you can do it. Any other questions that you guys have before we end the stream? I just realized I was on top chat instead of live chat, so hopefully that didn't affect the YouTube chat at all. Any questions you guys have before we end the stream? If not, that's all I got for you guys. So see you guys tomorrow on the next one.